So for question 39 from the reading, they tell you a compound has a half-life. So we know T 1/2 equals 5.2 days. Following typical first order kinetics, what percent of the original sample remains after 20 days? So my time is 20 days. And we want to basically know, okay, what is the percent of the sample that remains at that time, 20 days. So this is actually a challenging question. We have to use two different equations first because we're missing something, right? We know it's first order. So we know, okay, natural log of concentration equals negative KT plus natural log of my initial concentration. We don't know initial concentration, but we can make one up to make this question work. The other problem though, is we don't know rate constant. We can get the rate constant because we know half-life, right? T 1/2 equals 0.693 over K. I know the half-life is 5.2 days. So 0.693 over K. I'm going to multiply both sides by K. So that cancels out. So I get 5.2 days times K equals 0.693. Divide both sides by 5.2. And I get the rate constant for this reaction, right? 0.693 divided by 5.2, 0.1333 inverse days, right? So now that was part one. Now we can do part two. So to find a percentage, and like I said, we don't know my initial concentration, but just to make our life easy, we can call our initial concentration 1, right, for 100%. And then that way the concentration we find would just be a percentage that remains. So natural log of concentration at time t equals negative K. We just found our rate constant to be 0.1333 inverse days. We know the time is 20 days plus the natural log of 1. And remember, I'm picking 1 because they are asking for what percent of the sample remains. So by picking 1, it makes it easy to find, what is the remaining as a percent. And the other reason it's nice to pick 1 is because the natural log of 1 is 0. So that makes your equation that much easier already. So if we multiply these two together, all right, I get natural log of concentration at time t equals a negative 2.66 plus the natural log of 1, which is 0. So natural log of concentration at time t equals negative 2.66. And then again, just like before, right, E to the natural log of concentration equals concentration. That's how we're going to get our concentration. So E to the negative 2.66 equals .07. So multiply that by 100 to turn it into a percentage. And we see that about 7% of the sample remains after 20 days. And that seems reasonable because the half-life is 5 days. So we went through about 4 half-lives of that compound in that 20-day period. But it's definitely a challenging question. There's a lot we had to do to kind of use two different equations, find a rate constant from half-life, and then we didn't know initial concentration, but we're looking for a percentage. So our initial concentration is 1, then we can find our percentage remaining from there for question 39.